Hello. In last time we discussed about overview of vector algebra, dot product, cross product, and then we start coordinate system. There are total three types of coordinate system. First is Cartesian coordinate system, or you can say rectangular coordinate system. Second is cylindrical coordinate system, and third one is spherical coordinate system. And we have already completed first Cartesian coordinate system. So in today's lecture we start second coordinate system, which is cylindrical coordinate system. So let us start with second coordinate system, which is cylindrical coordinate system. So as the name implies, it's like as a cylinder. So in cylindrical coordinate system, it has a total three variables. Which are the three variables? Rho, phi, and z. So cylindrical coordinate system has total three variables: rho, phi, and z. So what is rho, what is phi, and what is z, that we have discussed in our today lecture. And what is the relationship between cylindrical coordinate system with Cartesian coordinate system, that we also discussed in today lecture. So here to understand the basic idea regarding the cylindrical coordinate system, first of all I have to draw the standard coordinate system is my rectangular coordinate system, or you can say that it's a Cartesian coordinate system which has a three axes x, y, and z. So now in cylindrical coordinate system, what we have to assume? We have assumed just one cylinder is exist. Okay, so here I have to put a cylinder on which plane? XY plane. So I have to just take one cylinder on XY plane. Okay, so here cylinder is present on this XY plane. Okay, that means the surface of the cylinder is present on the XY plane. So this one is known as positive x-axis. So this one is my negative x-axis. It is positive y-axis. Okay, so this one is my negative y-axis, positive z-axis. So it is negative z-axis. Okay, so now if I have to see this cylinder from the top side, so it is look like as a circle. Similarly, if I have to look the cylinder from the bottom side, so this look like as a circle. And if I have to see the cylinder from the top side, okay, so this look like as a rectangle. Okay, so now here first we will clear the idea about the rho. So what is rho actually? So rho is nothing but the radius of the circle of the cylinder that we have to see from the top side. If I have to see the cylinder from the top side, okay, I have to see the cylinder from the z-axis, from the top side. So this look like as a circle, and the rho is nothing but is a radius of that circle. Okay, so rho is nothing but is a radius of the circle. Okay, so this value is rho, this one is also rho, because actually from the top side it is look like as a circle, and as we know that the radius of the circle is same. Okay, so what is the radius? Radius is nothing but is the distance of the peripheral of the circle with respect to their origin. Okay, so these all are known as the radius of the circle. Okay, and it is rho. So it is known as rho. Now second thing is phi. So what is phi? Phi is the measured angle with respect to x-axis. Is in okay, so it is known as phi. So suppose I have to draw one line. Okay, for example, okay, after that we will take one example, and we will take one point. Okay, and how to represent those point in cylindrical coordinate system, that we will discuss. First of all, we have to clear the idea about this rho, phi, and z. So what is rho? Rho is nothing but the radius of the circle. What is phi? Phi is angle between x-axis. Okay, angle between our desired point to the x-axis. Okay, for example, suppose in Cartesian coordinate system, my point is in Cartesian coordinate system, for example, my point is 2, 3, and 4. Value of x, y, z is 2, 3, and 4. X is 2, y is 3, and z is 4. How to represent this point? So I have to cover 2 steps in x direction. I have to cover 3 steps in y direction. Okay, 3 steps in y direction and 4 steps in the z direction. Clear? So I have to cover the 4 step in the z direction also. Okay, so actually in xy plane, where is the point? Okay, for example, suppose it is 0, it is not a 4, for example it is 0, value of z is 0. So now the point is 2 3 0, so value of x is 2, value of y is 3, and value of z is 0. So the point is present here, this point P is 2 3 0. Okay, in Cartesian coordinate system. Now what is 5? 5 is the angle. Okay, phi is nothing but is an angle between two lines. Which are the two lines? The line which is passing through the point on the xy plane with respect to x axis. Okay, so this angle is known as phi angle. This angle is known as which angle? The angle is phi. Okay, so this angle is phi is nothing but is an angle with respect to the x axis. Okay, now what I have to do? I have to take another point. Okay, for example, okay, I have to take the point in the Cartesian coordinate system. Okay, suppose it is 2 3 4. Okay, so now where is the point? The point is x is equals to 2, y is equals to 3, and z is equals to 4. Okay, so now something, the point is present here. Okay, this one is 4. Okay, the point is something present here, which is 2 3 and 4. Okay, we have to assume the height of the cylinder is also 4. Okay, so now what is phi? So we have assumed the phi is the angle with respect to the line which is passing through the point with respect to the x axis. Okay, so now in this case, what is phi? So what we have to do? I have to draw one line which is arbitrary line which is parallel to my x axis. Okay, and one more line from the same center point which is passing through those point P, and whatever the angle that I have measured, this angle is nothing but it's the same angle which is phi. Okay, so here I have to observe the same angle, the angle is phi, this angle. Okay, it's a phi angle. Clear? So this both the angle are same. If you notice, this 5 and this 5, okay, both the value are same. Why? See, if you look, suppose here is your eyes, okay, and if you look from the top side, so this line and this line both are intersect, this line and this line both are intersect. Okay, so the value of phi and this value of phi remain same. Okay, so if you notice, for this point 2 3 0 and for this point 2 3 4, so what you concluded, we can conclude that this angle phi is independent on the z. Clear? The angle phi is independent on the z. It depends on what? It depends on the value of x and y only. Okay, so it is the meaning of phi. So what is phi? Phi is the angle between the line passing through the point with respect to x axis. It is known as angle phi. Okay, next, what is z? Z is nothing but it is known as height of the cylinder. Okay, the height of the cylinder is known as z. Clear? So this is a cylindrical coordinate system which is known as rho, phi, and z. Okay, so now I have to take one point and we have to draw, or we have to locate those points on our cylindrical coordinate system, and then after we'll find out the relationship between cylindrical coordinate system with our Cartesian coordinate system. Okay, so now for example, I want to locate some point. So locate the point in cylindrical coordinate system. The value of point P is 4, 45 degree and 5. Okay, so what it indicate? It indicate that 4 is nothing but this one is my rho, it is 5, and this one is z. Okay, so value of rho is 4, value of phi is 45 degree, and value of z is 5. Okay, locate this point in cylindrical coordinate system. So what I have to do? First of all, I have to draw x, y, and z axis. Okay, so I have to draw x, y, and z axis. Then here the value of rho is 4. So what is rho? Rho is nothing but is a radius of this circle. So I have to draw a circle which has a radius rho, that means the value of this radius is 4. Okay, so I have to draw, first of all I have to draw a circle which has a radius 4. So I have to draw one circle which has a radius 4. Okay, so it's a cylinder. Okay, so this one is my first step, to draw a cylinder, okay, which has a 2 circle from the top side and from the bottom side. We have to observe the 2 circle, and the radius of this circle is rho, which is 4. Okay, so this one is my rho, this one is my rho. Okay, this one is also my rho. Okay, similarly this one is also my rho, it is rho, this one is rho. Clear? Because actually from the top side and from the bottom side it is look like as a circle. Okay, then so first we have to fix the value of rho, which is 4. Then we have to fix the value of 5, which is 45 degree. And what is 5? 5 is angle with respect to x-axis. Okay, it is known as 45 degree. Okay, then what is z? Z is the height of the cylinder. So we have to adjust the height of the cylinder. Okay, I have to adjust the height of the cylinder is 5. Okay, so this one is my z, so I have to adjust this height, z is equals to 5. Okay, and now phi is equals to 45 degree. Okay, so where the point is present, phi is equals to 45 degree. So as we know, the phi is the angle between this x-axis, okay, and the line which is passing through the point. So here the point is present something here, this one is the location of my point. Okay, so this one is the location of my point. Okay, and which one is the 5? This one is a 5. This angle is 45 degree, this 5. Okay, now if you observe, okay, if I have to look this figure from the top side, okay, so what I have to observe? I have to observe a shadow of my point P. I have to observe a shadow of my point P here. Okay, this one is nothing but the shadow of point P. Okay, if I have to look this figure from the top side, so I have to observe a shadow of point P here. Okay, and again I have to draw one line on the xy plane which is passing through this shadow. Okay, and I have to measure the angle. This 5 will get the same angle, 45 degree. Okay, so where is the exact location of my point? This one is the exact location of my point in cylindrical coordinate system. Okay, so what is rho? Rho is the radius of this circle, which is known as rho. Okay, so actually the point P is present on the peripheral on this circle. Okay, what is 45 degree? Angle which is passing through the point with respect to the x-axis, it is known as 5. Okay, and what is z? Z is nothing but the height of this cylinder. Clear? Now, so this is just how to locate a point on cylindrical coordinate system. Okay, so now next topic is what we have to do. I have to just relate this cylindrical coordinate system with our Cartesian coordinate system. Okay, so now next topic is relation between Cartesian coordinate system x, y, z with cylindrical coordinate system rho 5 z. Okay, so if you notice one thing, which one is common? Z is common. Okay, here z is common. Okay, what is z here? This x, y, z axis, z is the height of the cylinder. Clear? So now how to relate it? So we have to just apply the trigonometric concept. Okay, it's very easy. So again I have to draw cylindrical coordinate system, so you can easily understand it. What is the relationship between x, y, z and rho 5 z? Okay, so it is again x, y, and z. I have to draw again here. This is cylinder. Then we have to apply a simple trigonometric concept. Okay, so suppose I have to look this figure. Okay, now I have to look this figure from the top side. Okay, I have to observe the figure from the top side. So here is my eye, and I have to observe the figure from the top side. Okay, eyebrow. Okay, so I have to observe the figure from the top side. So what we have to observe? We have to observe. See here, we have to observe here. This one is my y-axis. This one is my x-axis. Okay, here it is my negative x-axis. Here it is my negative y-axis. And where is z-axis? This one. Okay, out of page. The z-axis is out of page. So we have to say this one is my z-axis. Okay, and this portion, okay, is look like as a perfect circle. It is look like as a perfect circle. Okay, now suppose my point is located here. This one is the location of my point. Okay, similarly here. Okay, this one is the location of my point. But if I have to look from the top side, so we will observe the point is present something here, or the shadow of the point is something present here. Clear? So this one is the shadow or the point that I am interested. Okay, so we can say that this point cover some distance in x direction. This point also cover some distance in y direction. Okay, now how much amount of the distance the point is cover? So point cover y distance here, and point cover x distance. Okay, now what is phi? Phi is the angle between the line passing through the point and x-axis. Okay, so I have to draw a line which is passing through the point. And what is phi? Phi is the angle. Okay, so this one is angle which is phi. Okay, clear? So it's a clear-cut idea regarding cylindrical coordinate system. Okay, and what is now the question is, what is the distance of point P with respect to this origin? It is nothing but the radius of the circle, and radius of circle is nothing but it is rho. So this one is nothing but about is my rho. So rho is the radius of the circle. Okay, clear? So what I have to do, actually I have to observe my cylindrical coordinate system from the top side. This one is my eyes. Okay, so I have to observe this cylinder from the top side. So this look like as a circle. Okay, and this one is nothing but my point P, or you can say that this one is a shadow of my point P. Okay, so now I have to just apply the trigonometric concept. So here we have to apply which trigonometric concept? Simple, it's just sine theta and cos theta. Okay, see here I have to again draw this figure here. So this one is my x-axis, here it is y-axis. Okay, my point is present here, and this one is the location of my point P. Okay, so this point covers some distance in y direction, the point covers some distance in x direction. Okay, so this distance is x, this distance is y. Okay, and what is rho? Rho is the radius. This one is rho. Okay, this distance up to this distance, it is known as rho. It's a radius of the circle. Clear? And what is phi? Phi is angle with respect to line passing through the point P and x-axis. Okay, so now it's very easy for us. Now you have to apply just the trigonometric concept. Okay, so apply the trigonometric concept. So you can write what is cos phi. In this case, what is cos phi? Cos phi is equals to x by rho. Okay, cos phi is equals to x by rho. What is sin phi? Sin phi is equals to, this one is also y, this one is a y, this one is a x. So sin phi is equals to y by rho. And what is tan phi? What is tan phi? Tan phi is equals to y by x. Tan phi is equals to y by x. Okay, so again I have to write it in next page. So finally we can write cos phi is equals to x by rho, sin phi is equals to y by rho, okay, and tan phi is equals to y by x. Okay, so from this we can say that what is x? X is equals to rho cos phi. What is y? Y is equals to rho sin phi. And what is phi? Phi is equals to tan inverse y by x. Okay, this one is y. So y by x. Clear? So now it's a very clear cut picture. So now I have to write a relationship between Cartesian coordinate and cylindrical coordinate system. Okay, so first of all I have to write for the Cartesian coordinate system. Okay, so here what we have to just relate x, y, z with rho, phi and z. Okay, so what is x? So here x is equals to rho cos phi, y is equals to rho sin phi, and z is equals to nothing but these both z are same, so z is equals to z. Okay, so I have to write equation of Cartesian coordinate system in terms of cylindrical coordinate system. Next, I have to write the equation of cylindrical coordinate system in terms of Cartesian coordinate system. That means I have to write equation for rho, phi and z in terms of Cartesian coordinate system. Now what is rho? So if you observe, it's a triangle. So what is rho? Rho is equals to under root of x square plus y square. It's a right angle triangle. Okay, so it is under root of x square plus under root of x square plus y square. What is phi? That we have already derived. Phi is equals to tan inverse y by x, and here z is equals to z. Okay, so finally here we have to derive the equation for relationship between cylindrical and rectangular coordinate system. Okay, so you have to just remember these equations. Okay, now the question is, as we know that dot product and cross product, okay, that we have already studied about it, dot product and cross product. Okay, so for dot product and cross product, we know that some of the formulas like ax dot ax, answer is 0. Okay, sorry, answer is 1. Ax dot ax, answer is 1. Similarly, ay dot ay, answer is 1. Okay, similarly, az dot az, answer is 1. But what is ax dot ay? Ax dot ay, answer is 0. Okay, similarly we can write for the cylindrical coordinate system also. Okay, we can write in this way: arrow dot arrow, it is 1. A phi dot a phi, it is 1. Okay, az dot az, it is 1. Arrow dot a phi, it is 0. Similarly, arrow dot az, it is 0. A phi dot az, it is 0. Okay, so I have to write the dot product of unit vector in Cartesian coordinate system, and I have to write dot product of unit vector in cylindrical coordinate system. Okay, but now the question is, what is ax dot arrow? This one is my question. What is the answer of ax dot arrow? See here, we cannot say that ax dot arrow is equals to 0. Why? So look here, ax dot ax is equals to 1, ay dot ay is equals to 1, az dot az is equals to 1, ax dot ay is equals to 0. Why it is 0? Because here x and y both are the variable of rectangular coordinate system or Cartesian coordinate system. See here, rectangular and Cartesian both are the same word. Okay, the rectangular coordinate system is also known as Cartesian coordinate system. Okay, so in some time I have to call it Cartesian coordinate system, in some time I have to call rectangular coordinate system. Okay, so don't be confused about it. So ax dot ay is equals to 0. So actually x and y both are the variable for Cartesian coordinate system. Okay, so that is why it is 0. Similarly, a rho dot a5 is equals to 0. Why? Because rho and phi are the variable for cylindrical coordinate system for the same coordinate system, so that is why it is 0. But in this case, it is ax. And what is ax? Ax is a unit vector in x direction for the rectangular coordinate system, and this one is a rho, which is for the cylindrical coordinate system. Both are the different coordinate system. So what is the dot product? Okay, so this one is a question mark. Similarly, not only this one, what is ay dot a rho? Okay, what is az dot a rho? What is ax dot a5? What is ay dot a5? Okay, so there are so many questions. So how to solve it? So here just you have to remember one matrix. Okay, so actually this one is a very shortcut method that you have to just remember it. Okay, so you have to apply this shortcut method. So what I have to do, I have to just write first the unit vector for the Cartesian coordinate system, which are ax, ay and az. Okay, then after I have to write the unit vector for the cylindrical coordinate system, which is a rho, a5 and az. Okay, now it's very easy. Now what we have to do, first of all, I have to write for ax and a rho. Okay, so if you look this equation, x is equals to rho cos 5. Okay, similarly here x and rho. So here x and rho is present, just we have to put cos 5. So here I have to put cos 5. Okay, I repeat again, x is equals to rho cos 5. So x or ax is equals to rho cos 5. Similarly, y is equals to rho sin 5. So y is equals to, this one is rho or a rho sin 5. Okay, and what is az? This one is z. Okay, what is az dot a rho? So see here, actually z is also a variable for cylindrical coordinate system. Okay, so of course az dot a rho is 0. So it is 0. Okay, now next is what is ax dot a5. So what I have to do, I have to just take the differentiation of this first column with respect to phi. I do the differentiation of cos phi. The differentiation of cos phi is minus sin 5. Differentiation of sin phi is cos 5. Differentiation of 0, so it is 0. Okay, now ax dot az, relationship between ax dot az. So as we know that ax is a variable for rectangular coordinate system, az is also a for the rectangular coordinate, so ax dot az is 0. Similarly, ay dot az is 0, and last az dot az. Az dot az, so this 1, that we have already mentioned, so this 1. Okay, so now you can write in this way, what is ax dot a rho? Okay, now you can give answer very easily. Ax dot a rho is equals to cos 5. Okay, what is ax dot a5? Minus sin 5. What is ay dot a rho? Ay dot a rho is equals to sin 5. Az dot a rho? 0. Okay, ax dot a5 minus sin 5. Ay dot a5 cos 5. Az dot a5 0. Okay, so in this way you have to find out the dot product between two different coordinate. Okay, a dot product between unit vector of two different coordinate. First is rectangular and second is cylindrical coordinate system. Okay, so this one is the relationship between Cartesian and cylindrical coordinate system. Clear? So what we have studied in this lecture, we have studied about the cylindrical coordinate system. So there are the three variable rho, phi and z, how to locate it, and we have to find out the relationship between Cartesian and cylindrical coordinate system. So in next lecture we will discuss about next spherical coordinate system, and then will find a relationship between Cartesian and spherical coordinate system also. Thank you.